So, hello everyone. So my name is Wolfgang and I work for Quantum Brilliance. And today, or in the next 10 minutes, I have the pleasure to talk about a subject which I'm very passionate about and I now work about since 12 years. And this is about quantum hardware. So basically, the vision is, or everyone talks about quantum computing, right? And we just learned in the panel about all the great things we could do with it. But the problem is always, it always comes down to the hardware. The hardware is not there yet. We have a problem. We have to wait until the hardware is there. And that's true. So this is currently the big bottleneck, where there's a lot of different companies working on different technologies. And now we at Quantum Brilliance, we have a vision that with the technology that we would provide, we are actually able to create so-called quantum accelerators, and these are now deployable everywhere. So basically, when I joined Quantum Brilliance 10 months ago, it was this vision, this very kind of far-fetched future vision, that at some point the technology from Quantum Brilliance, which is based on diamonds, can actually be deployed on Mars. So what is Quantum Brilliance? Just very shortly, so it's a German-Australian startup with 2 locations with about 90 employees, which is like equally divided between our locations in Germany and Australia. And we are a full-stack company, which basically means we provide everything from the very raw materials. So we start with our diamond materials at the very bottom. Then we do the fabrication of the qubits on top. On top of that, we do the nanofabrication to actually build a quantum motherboard. On top of it, the software integration part, until actually also providing and demonstrating some real-life use cases. So now, the main vision we have now, right? So, and as I mentioned, there's all these different technologies, and we already heard in the panel that probably every technology will find their place and will find their very specific application where it will be useful in. So now, I strongly believe, and that's what I want to convince you, or just not convince you, that's the time is too short, to just interest you and provide you the perspective that I present, that diamond within this ecosystem provides now a new flavor which will actually kind of make quantum computing everywhere. So what is the problem actually with quantum computers or quantum computer hardware? So the problem is very similar to where classic computer was in the start. It's basically a mainframe problem. So it's a quantum computer today is very huge. It's had basically, it needs a huge fridge around it, lots of cables. So it's very expensive. It can only be eventually later on used in a cloud service for everyone. And the reason for this lies exactly in the quantum part. So it's quantum computing basically combines the quantum physics and 2 quantum effects, superposition and entanglement, together to actually allow now all the great quantum algorithms. And from a hardware manufacturing process, this actually means I don't actually have to make now classical transistors. I actually have to engineer quantum states. And engineering these quantum states is now very difficult because they're very fragile. So they're very small. It actually wants to interact with everything. So this makes it, you have to have a very perfect and very shielded environment. So this requires typically very low temperatures, and this is why you need these huge refrigerators, basically. So we already heard about, so quantum advantage is there, so you can do a lot of things with it, and I don't want to go more in detail on this. Just like maybe the take-home message would be, if you could have now all these great ideas which you could do with quantum computing, but now imagine you can do it everywhere. Not just in the cloud service where you need internet and everything. You could actually also have it on a satellite or in some mobile device in the desert, for example. And the answer and how this could be possible for us lies in diamond. So, and actually specifically in a defect within diamond. So although diamond can be very perfect, we can precisely engineer a specific kind of defect in diamond, which is the nitrogen vacancy center. And using now this electron spin of this defect, we can now use quantum computing. And because diamond is such a hard and perfect crystal, it actually in itself has this very unique environment from protecting now my qubit from the outside noise, which now allows it to be has basically the best properties at room temperature and is the only technology which would actually allow quantum computing at room temperature. So we now in Quantum Brilliance have basically from the hardware side one product at the moment. This is the Gen 1. It's a large case rack, which is commercially available at the moment. And the vision is in the next years to actually miniaturize it to actually like a lunchbox side, a graphic card kind of quantum computer. Actually, this is not just a 3D rendering fantasy object. We also delivered our first project to Parsley, which is a supercomputing center in Australia. And now if we now look inside this quantum computer and take it apart, so what do we actually see? So you have two big families of engineering. So one is the whole control side. So you somehow have to find a way to miniaturize how you actually control and initialize your qubit. On the other side, you actually have this mysterious quantum chip. And the idea is now by basically combining very standard fabrication techniques, which is very suitable for the larger scale stuff like the packaging or the nanostructuring on top, where you maybe have to fabricate some antennas, with actually now a new fabrication technology which allows you to actually place now these little NV centers exactly where you want it in a nice little array. And the technology we use here is already well established on different platforms. For example, in silicon, we actually use a nanotip to actually really manipulate a single atom on a diamond surface. So now, with this idea, and basically by combining this great advantages that the diamond material has with the great advantage of what our fabrication technique has for how to fabricate qubits, we can now actually bring quantum computers not only in the mainframe world, but also to the so-called distributed edge cases. And this now leads to a whole new school of different applications where you might actually be able to find a quantum computer. So actually our vision is not actually directly the quantum advantage where you have to now compete with a supercomputer. So everything I do on a quantum computer has to be better than what I could do on an equivalent supercomputer. Now I actually can go down with my requirements, so I don't need 1 million qubits. I mean probably just a lot less, because now I'm not computing with a supercomputer. I'm just computing with a classical like desktop computer or something, or like a graphic card. Yeah. And then now my time is already over, so hopefully you got a glimpse how we believe that diamonds are very important for the future for quantum computing. And feel free to contact me anytime afterwards if you have more detailed questions.